Yes, hi guys. So today I will talk about use of gamma functions in case of certain definitions, especially in case when limits 0 to pi by 2, then sin mx cos nx dx is equal to 1 or imn is equal to can be expressed in form of gamma function. What is gamma function? Let me briefly discuss about this. Okay, some requirements, required formulae which I have used here, which will be used in the solving of these questions. That let me explain. Because this topic, gamma function, beta function, will discuss in detail in in one of the next lectures, but it's not yet near to this lecture, but we after the completion of this or maybe one or two more lectures, series of lectures. After finishing them, then I'll take gamma, beta and gamma. So that is important. But here the use of gamma function is required because of that I have included what is gamma function. What is the value of gamma, or what kind of gamma function is used. Okay. Use of gamma function. Here let me take use of gamma function. What is the gamma function? What is symbol of this? Let me talk about something. Gamma function. Use of gamma function to express some definite integrals, more conveniently, more conveniently. Integrals more conveniently. So, use of gamma function to express some definite integrals more conveniently. Okay, so gamma function. Let me talk about gamma function. Gamma function is expressed by, now here I will talk about what is gamma function. And first, gamma function, we have to prove that this sin mx cos nx limits 0 to pi by 2 is definitely will be equal to gamma n plus 1 upon 2 into gamma n plus 1 upon 2 divided by twice gamma n plus 2 upon 2. This is the value. How it is equal to this, that are proved. But before that, let me take that what is this. Okay, gamma function, how these Wallace formula also, Wallace formula which I have discussed, will also be used here. And then that's the integral of this imn to be expressed in terms of im minus 2 and n. Okay, that are im minus 2 and n. And finally, when the m and n are even functions, or sorry, are even numbers, or when m is odd, n is even, n is even, or n is odd, or both are odd. In all the four cases, the same result will be obtained. That are discussed in detail. After that, I'll take these questions which are based on gamma function. So, okay, so let me first discuss what is gamma function is expressed symbolically. What is the symbol for this? Symbolically as gamma. Suppose this is n plus 1. Let me write here gamma n plus 1. This gamma n plus 1 pronounced as gamma n. Okay, pronounced as pronounced as gamma n plus 1. Gamma n plus 1. Okay, which is equal to n into gamma n. Further, it will be equal to n into n minus 1 gamma n minus 1. In this way, we will express this expression. Okay. So, for instance, let me write here. For instance, if I take a number, for instance, if I take gamma 4, this is equal to 3 gamma 3 equal to 3 into 2 gamma is equal to 3 into 2 into 1 gamma 1 is nothing but 3 into 2 into 1 into 1. Gamma 1 is also 1. Factorial 3. Okay, so gamma 4 is 1 lesser than factorial. Gamma 4 is equal to factorial 3. Factorial 3 we write like this. We know what factorial 3. And so let me put some important values here. First of all, gamma 1 is equal to 1. This is gamma 1. This is equal to 1 always. Okay. Then gamma 1.2 is equal to under root pi. Okay. So gamma 1.2 equal to under root pi. This we have to use here. 1 pi is equal to gamma 1.2. Okay. So let me further express them. Okay. And gamma, if I take 7 upon 2 is equal to pi by 2. Gamma pi by 2. This is 5 by 2. Equal to 5 by 2, 3 by 2, gamma 3 by 2 is equal to 5 by 2, 3 by 2 into 1 upon 2, gamma 1.2. So nothing but 5 by 2, 3 by 2, 1 upon 2 under root pi. This is under root pi or root pi. Okay, this is under root pi. So this is how we have to express gamma 7 by 2. We subtract 1 from this. It will be 5 by 2, gamma 5 by 2, but gamma 5 by 2 is equal to 3 by 2 into gamma 3 by 2, and gamma 3 by 2 into 1.2 gamma 1.2, etc. And 1.2 is equal to 5. These are the values of this. So these important values are here gamma n plus 1, which are written down here, written right here. Gamma n is equal to n minus 1 into gamma n minus 1. This is the value. Okay, or n plus 1, which are all written here. N plus 1 is equal to gamma n plus 1, which is equal to n gamma n. Okay, equal to n into n minus 1 gamma n minus 1. So in this way we decrease it 1 by 1, and this is how gamma 4 is factorial 3, gamma 5 is factorial 4, gamma 6 is factorial 1 lesser than gamma value. These are the uses of which we will use symbolically. Use these values in case of expressing functions already. Right here, what is the definite integral which we are going to express in terms of gamma functions? Okay, so let me prove that. Here, sign of integration limits must be 0 to pi by 2. Then this value sign mx cos mx into dx is equal to gamma. This is m plus 1.2, okay, into gamma n plus 1 upon divided by twice gamma n plus 2 upon. This we have to prove. This is to be proved by us. Okay. Whenever m and n are either even function both or both are odd functions, m is even, n is odd, m is odd, n is even. These 4 cases. We will discuss that this whole value. This gamma expression, this is gamma n plus 1.2, gamma n plus 1.2 divided by twice gamma n plus 2 upon 2. Okay, so this is the value of this, which in the first question there that are expressed there. This is to prove that how this is there. But let me take from the beginning. Now we know that what is the value of sign of integration. We remove this. This is question number 1. Question number 1, we have to prove sign of integration 0 to pi by 2. Sign of mx into cos of mx into dx equal to gamma n plus 1 on 2 gamma n plus 1 on 2 on twice gamma n plus 2 on 2. Okay, so this we have. Now let me take this. We know that first as per this definite integral, I'll put the limits after the value is obtained. Okay, so we know that sum of integration sine of mx cos mx into dx. Let me express this as sum of integration sine n minus 1x into sine x into cos of n x into dx. Okay. Now this is for differentiation sine mx and cos nx and sine x is for integration. So integrating it by parts. Integrating it by parts. Integrating it by parts. We get now this is the first function and these two are second function. Because cos x we substitute as n, so minus sin x dx equal to t, or minus sin x into dx equal to minus dt sin x, or let me take sin x dx equal to minus dt. We substitute this t raised power n, so t raised power n integrate minus t raised power n plus 1 upon n minus sin x equal to minus dt. That will be the integration of this. And then so it will be, so let this is I and n. This is I and n. Now integration. Okay, 0 to let me take first. I'm not writing this thing. The limits I'm not writing this thing. N minus 1x cos of nx sine of x into dx. Let me integrate this by parts. So first will be sine raised power n minus 1x into integration of this. This will be t raised power minus t raised power n into d. Why it is so? Let me write here. Putting cos x equal to t, therefore minus sin x into dx equal to dt, or sin x into dx equal to minus dt. This is t raised power n because cos x is here cos n, cos power n, t raised power n minus dt into dt. This will be then, so minus sign is there, it will be plus sign. Let me write second part here. It will be differentiation of this, be n minus 1 kind of integration. This is sine raised power n minus 2x, okay, into integration of this will cos raised power n plus 1 upon n plus 1 into cos x is differentiated again. Sorry, this has been done, but this we consider into dx again. Okay, so this is what, let me write it here. Finally we obtain the minus sine raised power n minus 1x into cos raised power n plus 1 integration upon n plus 1. This will be cos raised power n plus 1, similar like this, upon n plus 1. That is minus sign taken here. Okay, now plus this is n minus 1 upon n plus 1. This value. Sign of integration, this is sine raised power n minus 2x into cos raised power n plus 1 x into dx. I'm sorry. So the, but here sin x is again differentiated with cos x into n plus 2 n minus 2 into cos n plus 2. Okay. Now let me express this cos n plus 2 as, okay, so this value is there, but this must be n. How it can be n times? Let me write it there. So by further express this is minus sign n minus 1x, okay, n minus 1x into cos power n plus 1x divided by n plus 1 plus n minus 1 upon n plus 1. Now just let me write here sin n minus 2x as it is. Cos n plus 2 can be plus cos nx into cos square, which is nothing but 1 minus sin square into dx. Okay, so now let me further write down this. Now the left hand side we are having sin of integration plus sin mx into cos mx into dx. This we expressed in two terms, that's okay, but finally the result was this we started, this we started. This is equal to these two values. Minus sin raised over n minus 1x into cos raised over n plus 1x divided by n plus 1. Okay. Plus sin, the first step is n minus 1 upon n plus 1. Okay. So first step is sin raised over sum of integration. Sin raised over n minus 2x into cos of nx into dx. Second step is, if I multiply it by sin square, sin mx cos nx will be minus sin by minus sin there. It is nothing but n minus 1 n plus 1 n plus 1 the remainder is n plus 1. Sum of integration is sin mx by sin mx to sin square x and sin n minus 2x. Sin mx into cos nx into dx. Now this is a similar value like this. Take that this left hand side. We will obtain here. This is 1 plus n minus 1 upon n plus 1. Sin of integration, this is sin raised over. This we have done previously in the previous lecture. Nx into dx. This is all equal to this value, which is minus sin raised over n minus 1x cos raised over n plus 1x divided by n plus 1 is still on right, keeping this with plus sign. This value is n minus 1 upon n plus 1. Okay, sign of integration. This is n minus 2x into cos raised over nx dx. This are taken to the side. So what we have obtained here, n plus 1 plus n minus 1 means n plus n in the numerator. N plus 1 in the numerator, let me write here. So this value finally is, let me write here. So therefore, sum of integration sin raised power mx cos raised power mx into dx is equal to this value. Now dividing this n plus n will come in the numerator, n plus 1 n cancel out, n will cancel out. In the denominator we get n plus n minus sin raised power m minus 1x into cos raised power n plus 1x divided by n plus n. Here n plus n will come, but n plus n upon n plus 1, n plus 1, n plus 1 cancel out, n plus n is here, plus sign. This is nothing but n minus 1 upon n plus n. This value, sum of integration. This one, sin, this is n minus 2x into cos raised power nx. What is it? Let me take first equation. What do we see here? If I substitute the limits, so the limits then, this what we see here, this is nothing but the minus sin raised power n minus 1x cos raised power n plus 1x divided by n plus n plus n minus 1 upon n plus n. This is I n minus 2 comma n. This is I n n, which we have obtained. If I substitute the limits, therefore limit 0 to pi by 2, we get here sin raised power mx into cos nx into dx. This is what, now this will be 0. Why? Minus sin m1x into cos raised power n plus 1x divided by n plus n. Since the limit is 0 to pi by 2, plus this value plus n minus 1 upon n plus n. Sum of integration, this is sin raised power 0 to pi by 2 n minus 2 2x into cos raised power nx into dx. Okay. This value is there. Now what about this? 0. So when I substitute pi by upper limit, then cos pi by 2 is 0. It is 0. At 0, sin 0 is 0. This is 0. what we get here, this is nothing but n minus 1 on will be n plus n into sine of integration 0 to pi by 2. Okay, this is sine n minus 2x cos of n x into dx. What do we get similarly? We will obtain, if I further express this, if I express this further, only this term is obtained. This will be equal to then n minus 1 upon n plus n. Second step will be n minus 3 upon n plus n minus 2. Minus 2. Here we have to subtract minus into n minus 5 upon n plus n minus 4 and so on. Now if I take this as even integer, suppose it is even, it will be 2 minus 2, it will be 0 finally, only cos ns will be obtained. It will be, if it is even integer, if m and n are even, then what will we get? It will be 3 by, let me take 2 into 1 upon 2. Okay, and finally this cos n value, this is 1.2. Okay, or I'm sorry, this will be, because we are taking n plus n, here will be, this step will be 1 upon n plus 2 leave. Last step will be n plus 2. Before that it will be 3 by n only, n plus 4 is the answer. 3 upon n plus 4, this is step. Last step will be this, sine of integration, this is 0 to pi by 2, this is cos n x into dx, because sine for 0 will be 1. Here will come out this, because it is even integer, n will be finally 2 minus 2, n will be 2 minus 2 is 0. Here only cos ns will be obtained. What is the value of this? So this let me express with the help of Wally's formula. What is Wally's formula? But now we know that what is Wally's formula. Even if it is sine nx or cos nx, both have the similar value. So we know that from Wally's formula, from this be from Wally's formula. This is Wally's formula. Wally's formula. From Wally's formula, we have sine of integration 0 to pi by 2. Okay, let me take either sine nx or cos nx, both are similar. Let me do sine nx first. Sine nx into dx. What is the value of this? We express this as sine of integration. We know that what is this value? This is n minus 1 upon n, okay, n minus 3 upon n minus 2 and so on. Okay, and finally, if it is even integer, the last value will be 1.2 pi by 2. That will be there. That is the final value of this. Let me express this what it is. This is 0 pi by 2. If I write here sine n minus 1 x into sine x into dx. Now this is for differentiation and this is for integration sine x. The value. Now let me integrate this by parts. Integrating it by parts, we get this will be of sine therefore n minus 1 f as it is into sine x integration into minus cos x integration, we get sine x integration into dx 0 to pi by 2. This is also 0 to pi by 2. Here 0 to pi by 2. Let me first write. Afterwards I'll write the limits. First let me express this. First will be sine n minus 1 f as it is integration minus cos x integration of sine x. Sine x integration is minus cos x. This is plus sign here. Now differentiation of sine n minus 1 is n minus 1 will come before sine base power n minus 2x into sine x differentiated as cos x. Again, this is minus cos x minus sine r. Here plus sign. It is cos x and cos square x. So this is again cos x, because integration of sin x is cos x, so it is into cos dx. Okay, still I am not putting the limit. This will be 0 in case of limit 0 to pi by 2. It's 0 because if I write pi by 2, cos pi by 2 is 0. If I add 0, then sin 0 is 0. In both cases it is 0. Here 0 to pi by 2. Okay, what the value is? Let me write it. Plus this is n minus 1. Let me express this further. Sin pi by 2. Sin n minus 2x. Cos square x can be utilized. Sin n minus 2x into cos square x into minus sin square x into dx. Okay, so let me express this further. Finally, let me write here. So this will be n minus 1 sin of n is 0 to pi by 2. This is sin n minus 2 x into dx equal into 1 sin n minus 2x. Yes, and second will be minus sin n minus 1 sin of x is 0 to pi by 2. This is sin square x and sin n minus 2x is nothing but sin nx. This is similar value like this. So take transpose that last value to this side. We will get what? That t. Okay, so this will be 1 plus n minus 1. That means only n, so n minus 1 there. Then plus here, so plus n minus 1 here. This sin 0 to pi by 2. This sin nx into dx. Okay, so this is equal to this value n minus 1. Now let me divide by n. This is minus 1 plus 1 n. Divide by n. We will obtain here upon n minus 1 upon n value. Sin of negative this we have taken to that side 0 to pi by 2. And this is sin raised forward n minus 2x into dx. If it is even number, the last value will be sin is over 2 minus 2 0. That means what is the further process? The process will be n minus 1 upon n into n minus 3 upon n minus 2 into n minus 5 upon n minus 4, etc. Last value will be 1 upon 2. From this will be 0 power will be 1 dx, that means x. We substitute x as pi by 2, it will be pi by 2. Before that it will be 3 by 4 into 1.2, etc. Okay, so these are the even numbers in the denominator or numbers in the numerator. Okay, into pi by 2, last value. This is the sum of this value. I mean, similarly cos nx will be there. Cos nx will also be the same value. Okay, there is no doubt over this. Here it was negative in first place, but in this case it is positive first. The same value will come here also. If I substitute, therefore, substituting this second equation when both are even numbers. First, substituting this value from second to first in place of cos nx dx. What do we get here? Let me write it. Substituting the value from this Wallis formula. So Wallis formula. From Wallis formula, this we have studied that this value to be substituted in place of u to pi by 2 cos nx, because cos nx and sin nx both have the same value. Okay, so this will be, here it is m plus n. Therefore, this is equal to m minus 1 upon m plus n, m minus 3 upon m plus n plus minus 2 into m minus 5 upon n plus n minus 4 into and so on to 3 upon n plus 4 into 1 upon n plus 2, and these values finally. This will be then n minus 1 upon n, this is n minus 3 upon n minus 2, this is n plus n minus 2, and so on. Last value 3 upon 4, 1.2 into 5y. Okay, so this is the value of this one. If I divide numerator and denominator by 2, then what do we get? So further it can be expressed as m if I divide it by 2 each term. This is m minus 3 upon 2, m minus 5 upon 2, dividing numerator and denominator by 2. This we obtain here. This is 3 upon 2. Okay, this is 1 upon 2. This is n minus 1 upon 2. Again, n minus 1 upon 2, n minus 3 upon 2, and so on. This is 3 upon 2, 1 upon 2, 5 upon 2 here. 5 upon 2 I can take later. 5 upon 2 can be separated here. Let me write it. 1 upon 2 we are written here. This is 5 by 2. Dividing it by all these values are taken as. So this is m plus n upon 2, n plus n minus 2 upon 2. Okay, this is n plus n minus 4 upon 2, and so on. This n plus 4 upon 2, n plus 2 upon 2, n upon 2, n minus 2 upon 2, and so on, 4 upon 2, 2 upon 2, and finally this 2 will come here. This is right, okay. So this 2 upon 2, I have written down here 1 upon 2, 3 upon 2, 1 upon 2, and this 4 upon 2, 2 upon 2, here this is pi by 2. Let me write here this is pi by 2. Pi, because under root pi into pi. From the first step it will be under root pi because this is even integer. 1 upon 2 under root 1 upon 2 will be, if I write here, this is pi here, under root pi into under root pi. What function? That is because this pi can be written as pi is equal to under root pi into under root pi. Pi is equal to, and this 2 is taken here. Let me write this 2 here. Okay, so if I express this first step as m minus 1 upon 2, m minus 3 upon 2, m minus 5 upon 2, and so on up to 1 upon, and this pi under root pi. Under pi means under root 1 upon 2. This 1 under root pi you can take here. Okay, with with this one. This is one step. This is second step here. Up to this. So under root pi, if I write